I'm going to read aloud the section on matter that goes with your module page and the questions here. So, all right, what is matter? Take a look at the beautiful scene in Figure 1. What do you see? Perhaps you notice the water and ice. Maybe you are struck by the sun in the background. All these images show examples of matter. Matter is anything that takes up space and has mass. Matter does not have to be visible. Even air is matter. States of matter. All matter is made up of tiny particles such as atoms, molecules, or ions. Each particle attracts other particles. In other words, each particle pulls other particles towards itself. These particles are also are constantly moving. The motion of particles and the strength of attraction between these particles determine the material's state of matter. There are three familiar states of matter: solid, liquid, and gas. A fourth state of matter, known as plasma, occurs only at extremely high temperatures. Plasma is found in stars, lightning, and neon lights. Although plasma is common in the universe, it is not common on Earth. For that reason, this chapter will focus only on the three states of matter that are common on Earth. Solids. What makes a solid? Think about some solids you're familiar with. Chairs, floors, rocks, ice cubes are a few examples. What properties do they all share? Now, a solid is matter with a definite shape and volume. For example, when you pick up a rock from the ground and you place it in a bucket, it doesn't change shape or size. A solid does not take the shape of its container in which it's placed. This is because the particles of a solid are packed closely together, as shown in Figure 2. So you can see over here, this little diagram or picture of a solid shows each of those little individual particles, and they're so tightly packed together. In class, we'll use that example too of, can you imagine, if an elevator door opened and two people got in, there would be plenty of room. If 4, 5, 6 people came in, it would start to get a little bit more packed and more tight in there. And if you started adding 10, 12, 15, 20 people, you might be able to fit in an elevator. But you'd be just like this picture where everybody would probably be stuck in one spot. So, the particles that make up all types of matter are in constant motion. Does this mean that particles in a solid are moving too? Although you can't see them, a solid's particles are vibrating in place. These particles do not have enough energy to move out of their fixed positions. So those are moving. They're just, you can see these little lines here might show that there's vibration, there's motion, but they don't have the energy to break out of their fixed positions. So, crystalline solids. In some solids, particles are arranged in repeating three-dimensional pattern called a crystal. These solids are called crystalline solids. As you can see in the arrangement of particles in a crystal of sodium chloride, which is table salt, the particles in a crystal are arranged in the shape of a cube. Diamond, another crystalline solid, is made entirely of carbon atoms that form crystals that look more like pyramids. Sugar, sand, and snow are other crystalline solids. Amorphous solids. Some solids come together without forming crystal structures. These solids often consist of large particles that are not arranged in a repeating pattern. Instead, these particles are found in a random arrangement. These solids are called amorphous solids. Rubber and plastic and glass are examples of amorphous solids. All right, liquid. From the orange juice you drink with breakfast to the water you use to brush your teeth at night, matter in the liquid state is familiar to you. How would you describe the characteristics of liquid? Is it hard like a solid? Does it keep its shape? A liquid is matter that has a definite volume, but no definite shape. When you pour a liquid from one container to another, the liquid takes the shape of the container. The volume of a liquid, however, is the same no matter what the shape of the container. If you pour 50 milliliters of juice from a carton into a pitcher, the pitcher will contain 50 milliliters of juice. If you then pour the same juice into a glass, its shape will change again, but its volume will not. Free to move. The reason that a liquid can have different shapes is because the particles in a liquid move more freely, as shown in figure 4, than the particles in a solid. The particles in a liquid have enough energy to move out of their fixed positions, but not enough to move far apart. So here's that other description. You look at this little picture here compared to solids, it looks like, they do have quite a few particles. They are slightly packed together in this image here, but they are free to move around past one another. They're not stuck in that fixed position as you would see in a solid. They do have the ability to move and slide past one another. So using that elevator reference again too, that would be like if you had quite a few people in an elevator, maybe 8-10 people, you could maybe slide to the left or to the right just a little bit and move past somebody maybe to get to the back, but not very easily. There is the ability to move, but not to move as freely as you would like in there. So it's another couple words, one of these words being familiar to us. Viscosity. Do all liquids flow the way that water flows? You know that honey flows more slowly than water, and you've probably heard the phrase, slow as molasses. Some liquids flow more easily than others. A liquid's resistance to flow is known as the liquid's viscosity. Honey has a high viscosity. Water has a low viscosity. The slower the liquid flows, the higher its viscosity is. The viscosity results from the strength of the attraction between the particles of the liquid. For many liquids, viscosity increases as the liquid becomes colder. Surface tension. This is a familiar one with us because we just were talking about this last week when we did our penny drop lab. If you're careful, you can float a needle on the surface of the water. This is because of attractive forces that cause the particles on the surface of a liquid to pull themselves together and resist being pushed apart. You can see in figure 5a, right, you can see in figure 5a, there we go, that particles beneath the surface of a liquid are pulled in all directions. Particles at the surface of the liquid are pulled towards the center of the liquid and sideways along the surface. No liquid particles are located above to pull on them. The uneven forces acting on the particles on the surface of a liquid are called surface tension. Surface tension causes liquid to act as if there were a thin film stretched across its surface. As a result, you can float a needle on the surface of the water. For that same reason, the water strider in figure 5b can move all around the surface of the pond or lake. When a liquid is present in small amounts, surface tension causes the liquid to form small droplets, as you can see in figure 5c. And these are all the things that we had talked about last week, reading that article on water striders and using that surface tension to be able to glide across that surface, and how we saw those domes of water, the cohesive forces that formed on top of our penny, and kind of showing that between the hydrogen and oxygen in a water molecule, you can see the two hydrogens and an oxygen here, how those slight negative and positive attraction forces attract one another, and they tend to quote unquote hold on to one another. So, all right, so move on to our last one here too. Gases. Unlike solids and liquids, most gases are invisible. The air in airbags and the helium in balloons are examples of gases. Gas is a matter that does not have a definite shape or volume. The particles in gas are much farther apart than those in a liquid or a solid. Gas particles move at high speeds in all directions, and they will spread out evenly as far apart as possible. If you poured a small volume of a liquid into a container, the liquid would stay in the bottom. However, if you poured the same volume of a gas into a container, the gas would fill the container completely. A gas can expand or become compressed. Decreasing the volume of the container squeezes the gas particles closer together. And here's that same picture we've been looking at too about how those gas particles will fill that whole container. Remember when you saw these particles on the liquid? They all kind of slunk down to the bottom like this. Okay, it doesn't fill the whole container like you would see here with the gas particles too. They spread as far apart as they possibly can. All right. You'll sometimes hear the word vapor applied to gases. A vapor is matter that exists in the gas state, but is generally a liquid or solid at room temperature. Water, for example, is a liquid at room temperature. Steam, the gas state of water, is called water vapor. All right. I'm not going to do those questions here too, but all right.